right, hello, college algebra. Today we look at some more word problems, and instead of working with distance, rate, and time, we're looking at problems that have people working on a job. And the first thing that I want to point your attention to is that looking at distance equals rate times time, usually we're looking at the fact that miles, the amount of miles gone, is equal to the miles per hour times the hour. And you guys can see from physics, this equation makes perfect sense because if I put the hours over 1, the hours cancel and I have miles equals miles. Well, in a similar fashion, if someone is working on a job, the amount of the job that they can do is equal to their rate that they work on the job multiplied by their time worked. And usually we're looking at one job, or you could say the amount of the job done, usually it's 1, is equal to, usually we'll look at someone's rate as their job per hour, and usually they're working in hours. Now, this isn't always the case, but it does, sometimes we work in minutes, but usually, that's why I have usually, we look at it in this way. So let's talk through some preliminary questions, and then we'll get to the heart of it. So number 1, it says, if you can paint a room in 4 hours, what is your rate? Now, you might already know the answer, but we're going to develop this lesson using charts. So just like we did with distance, rate, and time. So instead of looking at distance equals rate times time at the top, we can say the job equals the rate times the time. And it says, what is your rate? So I'm looking at you. And I can fill in pieces that I have. So first of all, what is your rate? That's what I'm looking for. So I'll call this R, and I'm going to say R. You're going to see some subscripts in this lesson. So this would be, I'll call R sub Y, which represents the rate of you. Now, what do I have? It says that you do the job in 4 hours and you're completing 1 room. So you have 1 job. And you could put the units at the bottom. So this time would be hours. This would be the job per hour. And then this would be your job. Now, how could we solve for the rate? Well, if we know that the job is equal to the rate times the time, we know that your job, which is 1 room, is going to equal your rate, R sub Y, times 4. So then I can, obviously to solve for rate, I would just divide by 4, and I'd find that your rate is equal to 1/4, and now I'd want to include my units, 1/4 of the job per hour. And this makes sense well because obviously if I can paint a room in 4 hours, how much am I going to get done each hour? 1/4 of the job. So that's my rate, 1/4 of the job per hour. Okay, now let's see how we can use that. Number 2 says, if it takes Laura 3 hours to clean her room, what part of the job can she do in 2 hours? Well, I know that the part of the job that she can do is going to equal her rate times her time. Now, did it give me her rate? No. So let's start with the same type of chart system. I know that the job is equal to rate times time, and I'm looking at Laura. This is what I need to solve for. They did not give me her rate. So I'm going to say, I'm going to find the rate of Laura. And the reason that we have a little subscript is because soon we're going to be looking at multiple people. So we want to make sure that we can reference whose rate it would be. So this would be the rate of Laura. That's what it stands for. Stands for rate of Laura. Then now I want to see what I have. So it says it takes her 3 hours, 3 hours. And again, you can put your units at the bottom. Hours, and she's cleaning 1 job. It's typically 1 job. It doesn't have to be, but it's typically. So she's cleaning 1 room, or that's her 1 job. And if I'm looking at my rate, that would be job per hour. How can I determine that? Rate is going to equal, if you think about job equals rate times time, your rate is going to equal your job divided by your time. So I know that's going to be job per hour. Now we do need to solve for that. So in the same way, I know that the job is equal to rate times time. So Laura's one job is going to equal her rate times the time it takes her to do it in. So times 3. So we would divide by 3, and we can see that the rate of Laura is equal to 1/3 of the job per hour. So now I can go to the equation. It says, well, how much of the job can she do in 2 hours? So J, remember, that represents for the part of the job done, or we can say the amount of the job completed. What did I say at the top? Yeah, amount of the job. Amount of job completed is going to equal to the rate, which we're looking at Laura's job per hour, multiplied by the hours she works. So now it says, what part of the job can she do in 2 hours? So I know that Laura's rate times her time will tell us the amount of the job. What is Laura's rate? Laura's rate is 1/3. Found that here. So I'm going to put that in, 1/3 of the job per hour, multiplied by how much can she do in 2 hours? So this would tell me that she can do 2/3 of the job. So the amount of 2/3 of the room, you could say, or you could just say of the job. And you can see that's the amount of the job completed. Okay, if you need to pause or rewind, you can do that or stop and ask questions, but let's move to number 3. If Eric can mow 1/3 of the lawn in 3/4 of an hour, how long does it take to mow the whole lawn? Well, first we want to take a look at what we have and what we don't. So again, let's start with that chart system. So I know that I have job, rate, time. And I'm looking at Eric. And I know that he can mow 1/3 of the lawn. So the amount of the job that he can do is 1/3 in 3/4 of an hour. So the amount of time is 3/4. And again, I can say that this is the amount of the job. This is the time, and we're looking at in hours. So now they did not give me the rate of Eric. So I'm going to want to find what is the rate of Eric. And we know that to find the rate, the job is equal to rate times time. So Eric can do 1/3 of the job, and that's going to equal Eric's rate times his time, which is 3/4. And now I want to solve for the rate of Eric. So you guys know to solve here, we need to multiply by the reciprocal. And that tells me that Eric's rate is equal to 4/9. Okay, now I know Eric's rate. It's 4/9 job per hour. Jobs per hour. Now I'm going to use this information to help me solve the question. It says Eric can mow 1/3 of the lawn in 3/4 of an hour. I use that to find my rate. How long does it take him to mow the whole lawn? So again, I know that the amount of the job is going to equal the rate times the time. So now I'm looking at one whole job. So the amount of the job that I want to complete is one whole job is going to be found by taking Eric's rate, because he's the one working on it, multiplied by the time worked. So again, if you want to look at the units, his rate is in job per hour, and we're looking at how many hours does he need to work. Okay, so I know that the whole job is 1. The rate of Eric, I found that to be 4/9. So I'm going to go ahead and I'm going to pop that in. 4/9 times, now here's what I'm solving for, time. How long is it going to take him to mow the whole lawn? So to solve, I multiply by the reciprocal. I'm going to multiply this by 9/4, multiply this by 9/4, that cancels, and I can see the time that it takes him is 9/4 of an hour. We don't typically say that. We will say 2¼ hours. Or you could say 2 hours and 15 minutes. All right, but that's what we used. Okay, so far we've been working with one person. And when we work with one person, we can see that we always need to find their rate in order to solve the question about the job rate and time. So now in 4 through 6, we're looking at solving with 2 people. Number 4A says, Bailey can wash and wax a car in 4 hours. If Jason can do the same job in 3 hours, how much of the job could they do in 1 hour working together? Okay, so the first thing that I want to look at is I want to fill out the individual chart. There's 2 pieces going on here. There's Bailey and Jason working alone. So I want to call this one the job equals the rate times time. And we're looking at 2 people. We're looking at when Bailey works alone versus when Jason works alone. And we want to fill in what we have, what we know, and then we have to determine what we need to solve for each part of the chart. So it says Bailey can wash and wax a car in 4 hours. Samuel, not right now, honey. I'm doing a video. Sorry. Well, can you take it away from her, please?
I took one away.
Okay, thank you, honey. Okay, so Bailey working alone, she can do the whole job in 4 hours. So I know that Bailey. Okay, go ask Dad, okay? Bailey, can you go upstairs and get him? Samuel, not right now. Okay, so she can do the one job in 4 hours. And you could go ahead and say, well, this is one job, 4 hours. Now let's take a look. Do we know anything about Jason? We know Jason can do the same job in 3 hours. So he can do one job in 3 hours. Obviously, they did not give me the rate of Bailey and the rate of Jason. So that's something I'm going to need to solve for. Let me call that 1. So I need to determine what is the rate of Bailey and what is the rate of Jason. Now, if you prefer to work in the chart, you could use the fact that the rate is equal to the job divided by time, and you can use that to find their rates. Sometimes I like to work within the chart. Sometimes I just work off to the side. But for these beginning ones, I just really want to make sure we know how we're solving. So job is equal to rate times time. And if I'm looking at Bailey, Bailey can do one job in 4 hours. So I'm going to use that to solve for the rate of Bailey. So obviously we would divide by 4 and we can see that the rate of Bailey is equal to, she can do 1/4 of the job per hour. So she's 1/4. In a similar fashion, Jason can do one job in 5 hours. So I would say the rate of Jason times 3. Did I say that right? Sorry, my kids distracted me. So one job in 3 hours. So the rate of Jason would be found by dividing 1 by 3. So the rate of Jason is going to equal 1/3 of the job per hour. So 1/3. And we know that we're working with job per hour. Okay, this is working alone. Now let's take a look at a chart of them working together. When they work together in all of these problems, it assumes that the 2 people's rates remain the same, like the rate that they work is the same as if they worked alone. That's not always true. Sometimes when you work with somebody, you work faster. Sometimes when you work with somebody, maybe it's a friend and you goof off and you work a little bit slower, but we're going to assume that their rate of work when they're together is the same. So they're like robots. Okay, let's take a look. So I have now, this is going to be the information. You can title it at the top of the chart or on the side, but I'm looking for Bailey how this differs when she works together, and Jason, how the information differs when he's working together with Bailey. We know that the amount of job that they complete is going to equal their rate times their time. Now, as I said, their rates are going to be the same because working together or working alone, the rate that they can complete the job is equivalent. So I know that Bailey works on the job and she can complete 1/4 of the job per hour. I know Jason working on the job can complete 1/3 of the job per hour. Now it says, how much of the job can they do in 1 hour working together? So I know that the time that they're working together is 1 hour and 1 hour. Now, just like we did the questions yesterday when you had 2 people, Once you have two columns to fill in, you fill in the last column using those two. So we know that Bailey working together, the amount of her job is going to equal rate times time. So it's going to be 1/4 times 1 hour. And Jason's job, the amount that he can do, is going to equal his rate times time. So that's going to be 1/3 times 1. And this is the amount of the job done. Again, this is job per hour. And this is the time that they work together. Okay, now what did we do with the distance, rate, time? We set up an equation using the last column filled in. So now I'm looking at how it says how much of the job could they do in 1 hour working together? So we know that Bailey's work on the job plus Jason's work on the job will equal the amount of job complete. The amount of the job complete. And so now I'm going to fill these values in. So I have 1/4 plus 1/3 will equal the amount of the job that they've completed. So what do I need to do? I need to get a common denominator, multiply this by 3/3, multiply this by 4/4, and I can see that they have completed 7/12 of the job. So a little bit over half working together. So I would just say 7/12 of the job. Okay, let's see how we can use this information to even solve more questions or obtain more data. It says, how long will it take them to finish the job? How long will it take them to finish the job? So now I'm taking a look at the fact, if I'm using the chart again, they're not working for 1 hour. The time is the variable. So let's redraw this chart again. Practice makes us better. So I have job equals rate times time. We're looking at the job rate and time of Bailey when she works together with Jason. Jason together. We know that Bailey's rate of the job is 1/4 of the job per hour. Jason can do 1/3 of the job per hour. He's a little faster. Now it says, how long will it take them to finish? So now they're working for the same amount of time. So I'm going to call X that same amount of time that they're working. Now, when I'm looking at filling in the job column, job is equal to rate times time. So Bailey's amount of the job that she's going to complete is 1/4 times how long she works, 1/4 X. Jason's time together is going to be the same way, 1/3 times how long he works. Now I can set up an equation using the last column filled in. And again, it's going to be similar to this top one. I know that Bailey's work, I'll just say Bailey's part, that's her work on the job, plus Jason's part, that's his work on the job. Now I want to finish the job. So I want it to equal 1 whole job. And now I just fill these pieces in. So Bailey's part is 1/4 X. And again, I could just call that X over 4 because you'd have to multiply it by X over 1. Plus Jason's part is going to be X over 3. And this has to equal 1. So let me go ahead and call this, well, I'll just do it in another step because I'm not there. I don't want confusion. X over 4 plus X over 3 is equal to 1. And now this is a rational equation, and we know how to solve this. Multiply by the least common denominator. So I'm going to multiply this side by 12 and this side by 12. Distribute that in, and I'll get 3x plus 4x is equal to 12. So 7x is equal to 12, which means that x is equal to 12/7, or I would call that 1 5/7. Now, what was X? That was time. And we were looking at hours, job per hour. So the time it takes them working together, that's why this is the together chart, is 1 5/7 hours to complete the job. All right, let's practice some more questions together. Number 5, one printing press can finish the job in 8 hours. The same job would take a second press 12 hours. How long would it take both presses together? Okay, we have two things going on. We have printing presses that can complete jobs by themselves. So let's look at one chart for working alone. And then it talks about them working together. So then we'll create another chart for working together. Okay, let's start with working alone. I know that job equals rate times time. And let's call it press 1 and press 2. And it says one printing press, we'll call that press 1, can finish a job in 8 hours. So, I should probably distinguish this here more. Sorry. Press 1, press 2. So press 1 can do the one job in 8 hours. I need to solve for the rate of press 1 because they didn't give me that. Then it says the same job would take a second press 12 hours. So press 2 can solve the one job in 12 hours. I need to solve for the rate of press 2. How do I solve for a rate? I know that job is equal to rate times time. So if I'm looking at press 1, he can do one job using his rate times 8 hours. So the rate of press 1 is going to be 1/8 of the job per hour. So I'll say 1/8. Now, if I look at press 2, again, job equals rate times time. So press 2 can do one job in 12 hours. So the one job is going to equal the rate of press 2 times 12. Divide by 12, and I see that the rate of press 2 is 1/12 of the job per hour. 1/12. Okay, now working together, they're going to complete the job in a different amount of time because now they have some help. Oh, send me some help. I have sick kids. No, I'm okay. Okay, so now I have press 1 and press 2. Their rate doesn't change. Again, they're just presses. So if they can do that much alone, they can do that much of the job together. So 1/8 and 1/12. Now, what am I solving for? It says, how long would it take both presses together? So they're working for the same amount of time. So I'm looking for how long are they working here? How much time is press 1 working when he works together? And how much time is press 2 working when he works together? You can, again, always put the units at the end or at the bottom. So that's hours. This is job per hour. And this is how much of the job they're getting done. Now, just like with the distance rate time column or problems, when you have 2 columns to find the third one, you use the other 2. So job is equal to rate times time. So that's going to be 1/8 times X, and this is going to be 1/12 times X, or you could call that X over 8 and X over 12. In the same way we did the distance rate time problems, you always set up an equation using the last column filled in. So we're looking at press 1 and press 2 working to complete one job together. So my equation should be press 1, their part, plus press 2's part on the job has to equal one whole job. So I'm going to put that in, and I have X over 8 plus X over 12 is equal to 1. And I'm sorry, I have to text my mother-in-law because my kids are sick today. Well, my one kid is sick today and she can't come and I don't have my phone. So let me see if I can do this. Hey, Siri, text Lavonda.
What do you want to say?
Hi, Lavonda. I'm sorry. We don't need you today because Samuel has to go to the doctor. He has a really bad cough.
Okay, I'll send this.
Okay, so now I need to solve this. And to solve it, I'm going to multiply by the least common denominator. 12 is 4 times 3. That's 4 times 2. So 4 times 6 would be 24 is the least common denominator. 8 goes into 24 3 times. 12 goes into 24 2 times. 3 plus 2 is 5. So X is equal to 24 fifths. Or you could say X is equal to 5 goes into 24, 4 times 4 and 4/5. And what were we solving for? How long does it take them to complete the job together? So 4 and 4/5 hours. All right, let's do a few more and then I'll give you guys some time to work on homework. Number 6, it says one computer can do a job twice as fast as the other. Working together, both computers can do the job in 2 hours. How long would it take each computer working alone to do the job? Okay, so this one gives us information to start with about them working together and then asks about them working alone. So we want to take that into consideration. We're going to have 2 charts because we're looking at 2 computers. So we'll look at working alone and working together. We know that no matter how you work, the amount of job that you're going to do is going to equal your rate of completion times on the job times the time. So I can set those pieces up. Job is equal to rate times time. And who are we comparing? We're comparing computer 1 and computer 2. Computer 1, computer 2. Let's see what we can fill in. What information do we have? So it says they both can do the job in 2 hours. So we know that when they're working together, they're going to work for 2 hours and 2 hours. Then it says one computer can do a job twice as fast as the other. So this is something that I don't know. I don't know the rate, but I do know that one is twice as fast. So if I'm looking at the rate of computer 1, if I called it, for example, X, computer 2 would be going twice as fast. So let's say he's going 30 miles per hour, he's going 60 miles per hour, just twice as fast. Now they're doing a job, so that's one job and one job. So how can did it tell me how long computer 1 would take to do one job alone? No, that's what I'm solving for. How long will it take the computer to do one job alone? So I know that time, if I'm using the 2 columns, job equals rate times time. So time is going to equal the job divided by the rate. So this is going to be the job divided by the rate, which is 1 over X. And this is going to be 1 over 2X. Okay, that's important to fill those pieces in. Now, I do have that this is the job per hour, and this is the hours of time. Now, let's go ahead and fill in the pieces that we know in the other chart. The rate, we know the rate is going to be consistent. So if this is X and this is 2X, I can basically just copy that to the other chart, X and 2X. Now I know the job is going to equal the rate times time. So computer 1 is going to be 2X and computer 2 is going to be 4X. We always set up an equation using the last column filled in. So looking at this piece here, I know that the computer 1 part plus computer 2 part is going to equal 1. So I know that 2X plus 4X has to equal 1, or you could say 6X has to equal 1. Divide both sides by 6, and I can see that X is equal to 1/6. What does X represent? X represents the rate of computer 1. So X is the rate of computer 1. They didn't give that to me. They just told me one had a rate and the other one was twice as fast. Now, what does it say? It says, how long would it take each computer working alone to do the job? So this piece and this piece are what I need to solve for. That's the time working alone. So I would say computer 1 working alone would be 1 over X. So in this case, it's going to be 1 over, and I'm going to bring the 1/6 up. So I'm going to go ahead and solve for that. You guys know that if we're taking 1/1 and dividing it by 1/6, to do that, we multiply by the reciprocal. So that'd be 1/1 times 6, which means it's going to take computer 1 6 hours. Okay, computer 2. Computer 2 working alone is going to be 1/2 times x. So that's 1/2 times 1/6, aka 1/2/6, aka 1/1/3, aka multiply by the reciprocal 3 hours. So computer 2 is twice as fast. It should take them half the time. So 3 hours, and computer 1 would take 6 hours. All right, moving right along. Last one, number 7. An installer can carpet a room in 3 hours. An assistant takes 4.5 hours to do the same job. If the assistant helps for 1 hour and then is called away on another job, how long will it take the installer to finish? Okay, so let's put these pieces in. Job, rate, time. And let's look at this one. They're working alone. And this one is they're working together forever. No, just for an hour. Okay, so we got job is equal to rate times time. And who are we working with? An installer. He sounds so professional. And then his assistant. And same here, installer and assistant. And it says an installer can carpet a room in 3 hours. That's by himself, which means that it takes him 3 hours to do 1 room. The assistant can do the same job in 4.5 hours. So I'm going to call that 4.5 hours. He can do the same job. Did they give us the rate of the installer? Did they give us the rate of the assistant? Why no, we're going to have to solve for that. The rate of the installer, and the rate of the assistant. But you're in luck. I know how to solve for rate. Job is equal to rate times time. So if I'm looking at the job of the installer, he can do 1 job is equal to his rate times 3. So the rate of the installer is going to be 1/3 of the job per hour. 1/3. Nice. Okay, I'm going to call this guy 9/2 because it's going to be easier for me to work with it mathematically. So I know for the rate of the installer, the job is going to equal the rate times time. Or sorry, the assistant. We're on the assistant. Don't confuse him. He still has some work to do. Okay, so the assistant, he can do 1 job in 9/2 hours. So his 1 job is going to equal, or the amount, his job will be completed by using his rate times 9/2 because he can do the whole job in 9/2 hours. So how do we solve for that rate? We've done this before. Multiply by 2/9. So the rate of the installer is 2/9 of the job per hour. He's not that much slower than the installer. He's doing good. Okay, now I know that the rate working alone is going to be the same as the rate working together. So this is 1/3, this is 2/9. But now they're working together. So their time of completion is going to be different. They have some help. So it says the assistant helps for 1 hour, 1 hour, 1 hour. And then the assistant helps for 1 hour. So I guess I could say that. But then the other one's called away. So they only work for 1 hour together. So the amount of the job, remember, this is the amount of the job. Usually it's 1, but not always. This is the rate, which is job per hour. And I know that the amount of the job is going to equal the rate times the time. So how much does the installer finish in 1 hour? His rate times his time, 1/3 times 1. He's going to complete 1/3 of the job. How much does the assistant complete in 1 hour? 2/9 times 1, because they only work 1 hour together. Then they're called away. So I know there's no variables here, but we can determine how much of the job they complete together. So the installer's part plus the assistant's part will equal the 1 job. or sorry, not the one job. It will equal the part of the job done. Usually it's 1, but they only worked an hour, so they're not done. How much have they completed? They did 1/3 plus 2/9. So that's going to tell me that they completed 5/9 is the part of the job completed. 5/9 of the job is completed. Okay, so that's how much they've done together. Now it says, how long will it take the installer to finish? So the question is, if they've completed 5/9 of the job together, how much more of the job needs to be finished? So I'm going to write that. They completed 5/9 of the job together, which means they have, well, you could do 1 minus 5/9. They have 4/9 of the job to finish. And when I say they, I should probably say the assistant. So when I say they, really the installer left. He went on another job. So the assistant has 4/9 of the job to finish. Well, how can I determine how much time it will take him to finish? Well, I know that the job will equal, if I'm working with the assistant, the rate of the assistant times his time worked. What pieces do I know? I know the amount of the job he needs to finish. He doesn't have to finish a whole job. He has to, that's supposed to be a highlighter. He has to finish 4/9 of the job. So I'm going to see 4/9 of the job is going to equal, do I know the rate of the assistant? Well, yes, I do. That's 2/9 times, I don't know what happened with that, but that's supposed to say T, J equals R times T. So that will tell me how long he has to finish. Now to solve, I know to multiply by the reciprocal, so I'm going to multiply both sides by 9/2. And I've completed 5/9 of the job. They have 4/9 of the job. And so if he has 4/9 of the job to finish and he can complete 2/9 of the job per hour, then the time he would take to finish would be 4 divided by 2, which is 2. But I know that's, what did I do? Did I make a mistake? 1/3, if I multiply this by 3/3, 3 plus 2 gives me 5/9, which tells me he has 4/9 of the job to finish. He can do, he can do 2/9 of the job per hour, times that by 9/2, times that by 9/2. And that would tell me that he has to work for 2 additional hours. And why am I pausing on this? The installer can do 1 job in 3 hours. The other one can do 1 job in 4.5 hours. 4.5 is the same as 9/2, which means job equals rate times time. So the rate is going to equal 1 divided by, oh goodness, I made a mistake right here. Because, no, I didn't. Per hour, 2/9. 2/9 times 1, 1/3 plus 2/9. 5/9. Which means he has 4/9 of the job to finish. 9/2. Oh, I know the answer is 1 1/3. So what is it that I did incorrectly? Let me look at my completed notes. Sorry, guys, it's been a morning and I don't know what it is that I made a mistake on. But the good thing is I did this homework. I did this before And I was trying to do it Mr. Roy's way, which, let's see, 4 nights. Installer. Did I mix up the installer and the assistant? It says, if the assistant helps for 1 hour. Oh, thank you. Sorry. Wish I was there with you guys. You guys catch me on little things like this. If the assistant helps for 1 hour and then is called away on another job. So the assistant is called away. It is the installer that needs to finish, the faster guy. Meh. I'm sorry, guys. So it's not the assistant that has to finish. It is the installer. I knew the answer was 1 1/3, and I was like, what is wrong with me? But it's early and my kid is coughing up a storm, and I'm sorry. So the installer has to finish, which means we actually need to use the rate of the installer, which is not 2 nights. He's faster. It takes him 1/3. He can do 1/3 of the job per hour. Now I can multiply by 3/1, 3/1. And now the 3 cancels and we have 4/3 or 1 1/3. So it's 1 1/3 hours. Sorry for the mistake on that one, guys. You have the rest of the time to work on the homework. I do have all of the worked out solutions online. So I would say try it on your own, each question. And then if you're really stuck, look and see if you can figure it out from the work, and we'll go over